Greetings, the Astro 30 here, and welcome back. And if you're new to this channel, welcome. Today I've got another one of these REL Acoustics Limited subwoofers sitting on the desk here to look at. And according to the complaint, bit of damage. According to the complaint, it fries drivers as well, just like the little white one did. This one's slightly larger, so I believe this one's a 10-inch version and the other one was an 8-inch version. The REL Acoustics badge is actually missing off the front here. There's remnants of sticky stuff where it used to be, so it's fallen off. I'll just turn it around so we can look at the amplifier at the back. Now it's quite weighty, so I'll turn these levels up for testing purposes. It's a REL Acoustics Limited, as I said, and it's the T1 sub-bass system. Brigand Wales UK, www.rel.net. Interesting. It's got a fairly hefty sized heatsink on it. The first thing to do would be to plug it into the dim bulb and see what it actually does. Okay, it's plugged into the dim bulb and the main switch is turned on, so I'll turn the dim bulb on. Absolutely nothing. Not even any inrush. Okay. And, yeah. That fuse is deader than Marilyn Monroe. And it blew with quite a bit of force too. So in order to continue testing, I'm going to have to put a new fuse in. I don't have a 3.15 amp slow blow fuse, but I do have a 3 amp fast blow, which I'm going to use for testing purposes on the dim bulb. Well, that's a good sign. The dim bulb glowed quite brightly and then slowly dimmed out to almost nothing. So it's a good indication that we haven't got a direct dead short anywhere, which is good. That's a good start. There is a quite considerable amount of inrush current. So I've got the subwoofer upside down and I've actually got a multimeter hooked across the output leads now that I know that the relay engages, etc. I want to see what DC offset we have on the output, which is slightly awkward because of the size of the cabinet, but I'll turn him on. Oh yeah, yeah indeed. Looks like we've got the positive supply rail across the output, which is, yeah, not good. So I'll turn that off. So what I have to do is I have to pull the amplifier chassis out of the cabinet and get the cabinet out of the way. However, that does prove one problem because it uses a toroidal transformer, which is not actually mounted to the chassis, it's mounted to the cabinet by some bolts. So in order to test this unit on its own outside the cabinet, I'd have to remove the toroidal transformer with it, which makes it slightly more awkward. But first what I'm going to do is I'm going to remove the amplifier out of the cabinet and lay it on the desk, and hopefully the leads from the toroidal transformer are long enough. I just want to take a couple of power supply voltage measurements first, just to make sure that all the supply rails are there. See, that's what I mean. There's a big, I think it's about a 500 VA toroidal transformer sitting there, but there's a bolt either side of it. As you can see, there's one at the bottom left of the screen there, and there's one at the top right, which you can't really see because the wires are in the way. But it also looks like they've lengthened the wires coming off of the transformer and put heat shrink over it. Interesting. However, from what I can see, there might be just enough length here on these wires for this to lay out sideways. And there's a good look at the amplifier board. It's similar in design to the other one. A few components have been moved around. And it looks like they've employed some voltage regulators or something over here. That may be for the plus minus 15 volt rails, because it does have an op amp on the board. It has the same input board as the other one, so I'm hoping that's not damaged. That'll be another thing that I'll be checking to see if there's a signal coming off of that. Because of that epoxy crap all over it, which is covering the SMD components, well, if there's anything damaged there, it's going to be awfully hard to repair. So let me get the amplifier chassis out of the cabinet so I can do some further testing. And, well, the amplifier is born, but those leads are not long enough. Thoroughly frustrating. Okay, I'm going to take the transformer out of the cabinet because it's going to be awfully awkward otherwise. I got the bracket out, but unfortunately it took out this thing that you screw into out of the wood, so I'm going to have to like screw and glue that back in, I guess. But yeah, well, whatever. There we go. Now I can move the cabinet out of the way, and I'll fix this screw-in nut thing as well whilst I'm at it. There we go, now I'll never know. I just used the bolt to screw it back in. Luckily this stuff's MDF or craft wood, it's not actually chipboard or anything. So yeah, it's only because the screw was so tight and all the glue and crap they put around it made it impossible to undo. But in order to get the transformer out of this, you've got to unbolt all 3 bolts that hold it in and then just pull the transformer out. Right, now that I've fixed the problem that I caused, I can now get the cabinet out of the way and we can just resume some testing. Yeah, that's not awkward at all. There's just not enough length. Oh, there's a rubber thing there, that's good. There's just not enough length on these AC wires connecting to the AC board to reach. So yeah, I have to set the transformer there. But this is only temporary, so I can test some power supply rails, and I believe that this plugs into the 230 volt marked connector, not the 110. So CN3, not CN2, I think. Yeah, that's right. Now I'm going to measure across each collector of the NPN side, because these are 2SC and 2SA transistors. They're not MOSFETs or anything, but they're beefier than the other one is. So I'm going to measure between the collector and collector of each side to see if we have roughly 120 volts DC on the supply line. So I'll turn it on and grab my multimeter leads. Now, if you're following along at home, you do so at your own risk. There's high DC voltage here. So from each collector PNP and NPN respectively, we've got about 100 volt DC there, which is a little less than what we're seeing on the output, but yeah, it's okay. So what I want to do now is I want to measure the plus minus 15 volt rail, so we should have 30 volts across that op amp on the main board, but the easiest place to measure it is at this connector at the input board across, well, these 2 connections. Well, according to that, we've only got minus 14 volt, which can't be right. So there's an op amp buried down here that you can't see and I can barely see it. So across pins 7 and 4, it's only 12 volt DC there, which gives it a plus minus supply rail of 6. Because if I now measure across ground, well, we got 13 volt there on pin 7. And nothing on pin 4. We've got a couple of IRF540 MOSFETs down here, which I'm assuming are the pass elements for the plus minus 15 volt rail, assuming that it's supposed to be plus minus 15 volt. So the thing is off at the moment, so I'm just going to measure. That's dead shorted. That's dead shorted. That one's fine. That's saying 0.3 of a volt across gate and source, but this one, dead short across gate and drain, dead short across gate and source. The other one, however, I've got the leads probably the wrong way around, is not shorted. That one's functioning fine. If I switch those leads around, it probably measure differently. No, there's nothing there, so there we go. It's, yeah, 0.3 of a volt there across gate and source, but that's fine. There's nothing across gate and drain, so looks like this MOSFET is shorted. So that could be the reason why we've got no negative voltage rail to the op amp, which could be a reason why we have a DC offset. So that means I'd have to replace that transistor for a start. Let's just check. I believe they're Zener diodes. Yes, I'll just check its Zener diode which goes with it. It also appears to be shorted. Its companion is saying 0.3 of a volt, which is fine. Ugh. So it appears that this Zener is shorted as well, but that may be because of the MOSFET, so I'd have to remove the MOSFET first just to see whether or not that diode is indeed shorted, and that MOSFET is indeed shorted. So that means the board's got to come out, which is going to be fun. At least these unplug easier than the last one did. Bugger, a wire just came out of that connector. I'm going to have to fix that too now. It's all this circuit glue crap that they use. Makes it awfully difficult to unplug them. This is a big blob of crap in the way. It's only for the thermal overload switch, and it looks like a standard 2-pin JST connector, so I'll just put another one on. So I'll cut this wire here to separate that connector from the thermal overload switch. Actually, no, that's not for the thermal overload switch, that's for the LED. So yeah, that's going to have to be addressed, and I have no idea which way is which. So when I come to wire the new connector, I'm going to have to make sure that I wire it the same way as this. In fact, I probably don't have to redo this pin, just one. Could probably just put a new crimp on it, you know. Anyway, I'll deal with that later. So I'm going to pull transformer connections off the board if I can. There we go. And I might remove the transformer altogether out of the way. And then I can go about unscrewing this main PCB. So I've got the board out, and I have got the MOSFET off the board. It took one of the pads with it, but that's alright. It wasn't connected to anything anyway. I can probably take that back off and just sit it on top of the board. But if I measure across the MOSFET now, it's shorted. It's done. Yeah, completely shorted across all pins in any direction. So that MOSFET is done. I also lifted one end of that Zener diode out so I could test it out of circuit, and it indeed tests fine. It's not shorted. So it's not even beeping, and it's giving me 0.73 odd volt drop there, so that's fine. That diode can go back in circuit. Okay, so I've soldered the diode back in, and I've cleaned the holes out where the IRF 540 went, and I've looked up the IRF 540, and JCar do sell them, but they're nearly $8, which is quite expensive, but then again, yeah, it is a MOSFET. As for the damage to the pad on the other side of the PCB, whereas we see there is a white spot here now where the pad used to be, that they should be gold coloured. It's actually stuck to the end of the MOSFET pin. But there's no actual trace on this side going anywhere to that pad, so it could probably most likely do without it. However, I might try and save the pad off of the MOSFET and just like maybe super glue it to the PCB, or just when I'm passing the component through and soldering the component, I'll just make sure it's soldered on with it. I don't know. So yeah, that's the upshot. I'm going to have to replace that MOSFET because I can't test it any further if we don't have the minus 15 volt rail, which I believe that's what that MOSFET controls. And the easiest way to test if a MOSFET is good or bad is we should have no continuity between drain and source. So the red lead would go on the source pin, which is there. Sorry, the drain pin, and the black lead goes on the source. we have no beep. I'm on diode mode, and as we can see, the voltage is fairly high and climbing, so that MOSFET is perfectly fine. Now, but that one sitting on the desk is not. So I'll have to get another MOSFET, put it in, and see if we get any different results. That may be the only fault with the whole entire thing, is it's missing the minus 15 volt rail, which would make sense because this particular op amp here does control our input stage section of the power amp, which is basically giving us our long tail pair or differential, and negative feedback needs to come into, in this case, pin 2 from the output stage, and pin 3 is where the input comes in from the outside world. Now, the op amp's not going to function if the negative rail is missing, and yeah, it'll have no output for a start, and it won't, the differential pair on the input stage won't work correctly, so that could be an indication why we have a DC offset on the output of almost a positive rail, because, well, the differential pair is not actually working or functioning, and because they're not actually getting a negative reference anymore, well, they're not really doing anything. There might as well just be a diode there for all that mattered. So yeah, I'll get a new MOSFET, pop it in, hopefully it doesn't blow it up, and see if that makes a difference. If we look at the underside of the PCB here, the source pin of the MOSFET is actually connected directly to the collectors of these two NPN transistors. And if we follow the drain pin, the center one, all the way across the circuit board, it goes all the way back over here to the positive side of the bridge rectifier, which is just here. So this MOSFET is actually controlling the voltage on the collectors, because this is a emitter-follower amplifier, so all the emitters are joined via degeneration resistors to the output point. So this collector is getting its positive rail reference from the MOSFET. So yeah, that's what that MOSFET controls. It doesn't control the negative rail to the op amps, but it is controlling the positive rail to the NPN transistor, which is, well, we're getting a positive output, so it's like these two transistors are conducting and these two are not. It's kind of confusing to explain, but yeah, this is my finding. That's what this MOSFET is doing, is actually supplying the positive voltage reference to the collectors of the output stage on the NPN side for whatever reason. So if I replace that MOSFET and the DC offset goes away, well, it could be a good indication that we've now got a working output stage. But I've tested all the output transistors, they seem fine. These other transistors on the other side, because it's the same as that other white one, we've got two transistors down here which control the positive and negative rails to that op amp. So it's not really, and xenodiodes down here which you can't really see. So it's not really that intuitive of how it's designed, but yeah. You've got two transistors over here which are driving the MOSFETs, I assume, or acting as error amplifiers. Two Xenos here. So what is actually, what voltage it's actually supplying to the collector, I don't know. But yeah, these MOSFETs are being used as regulators to give a regulated output voltage to the output stage. And the only reason I can see them from doing that is so that you get a stable output power, and it's not affected by, you know, difference in the variation of the AC mains voltage. Sometimes it can be like 230 volts, sometimes it can be 240 volt, etc. So yeah, they're using that to just regulate the positive and the negative supply rails to the output stage, I suppose, just to keep it stable. Yeah, but that's all I've found on this so far. I'm going to test some other components around the circuit, like the Zenas down here, just to make sure that they are conducting, because yeah, we're still missing the negative rail to that op amp. But yeah, I'm getting somewhere, I guess. I see what they're doing here. On the other side of the board, we've got two large dropper resistors and these two large diodes here. Now, each end of the diode that doesn't connect to the resistor, so this one connects directly over to this resistor here, and the other resistor is here, so that means that this diode here connects to that resistor, and these resistors go across the Zener diodes, etc., as a shunt regulator. Now, the other end of these diodes, this one goes up to the collector of the PNP transistors, right? So that's coming off of the drain of this MOSFET. I believe that's the drain. I can never remember yet. The center one's the drain. And conversely, this diode here at this end comes off of these collectors, which is off the source of this MOSFET. So the driver transistors, which are over here, and here, I've tested them, they work fine. They also connect off of either the drain of this MOSFET or the source of this MOSFET at their collectors, because the collectors connect directly to the collectors of their associated transistor, which in this case is that collector goes to that collector, this collector goes to those collectors. So they're using these as voltage regulators as well, but it's also supplying voltage down here to our lower supply voltage. There is another winding, secondary winding, that comes into the PCB here. I'm not sure what that winding is for, but it may be the lower control voltage for the MOSFETs on the gates, like for the gate driver. So, and then this is the high powered side, which then comes across either the drain or the source respectively and powers the rest of the circuit. I find this very interesting, actually. Yeah. However, this MOSFET controls the positive going side of the supply rail, so not having negative 15 volt at the op amp is still not proving what the issue is there. So, but I'll replace the MOSFET and we'll do some further testing on the dim bulb just to make sure it's not going to go up in smoke, or there's another more serious problem, which is what took the MOSFET out. However, as to what took the MOSFET out in the first place, well, it could have been one of two things. The output was shorted, or when there was the DC offset originally, which is what the original fault is, was on the output, and then the output stage was then connected to a load like the speaker. It drew excessive amounts of current, took out the MOSFET and took out the fuse that went in line with the AC cord with it. Those are the only two possibilities. Power surge on the mains may have caused damage. It's unknown, but he did say that it was frying drivers, and it probably fried the driver, yes, before it blew the fuse. So, because I don't see him replacing the fuse. So yeah, that's why this MOSFET is probably dead, is because, or shorted, is because excessive amounts of current went through it that it could not handle. Like a short circuit, for instance. So, yeah, I'll get that replaced and continue further testing and see what happens. Hopefully nothing goes off with a bang, and if we still have the original DC offset problem, well then and we have no negative 15 volt rail, I'm just going to have to look elsewhere. This is the fun of fault finding. And through the process of further investigating before buying any parts, I've also discovered why we've got no negative 15 volt rail. The negative 15 volt rail comes off at this point, on this resistor, which is a 1.5K, and that goes to that pin, if I was on the right setting, goes to that pin there because we've got 0 ohms. Alright, and this one goes to the pin next to it, which should be the positive. And this goes through a resistor over here somewhere, which goes through the base to the base of one of these two transistors. I can't remember which one offhand, it's one of them. And then connects on its emitter to pin 4. So the emitter being there. It's this transistor here. So there's a resistor connected to the base here somewhere. Right there. That resistor then connects to this point, say 0 ohms, and if I measure across the resistor, it's in mega ohms. It's not reading. This resistor is open. I cannot get a reading. This one tests fine. About 1.45K. So this resistor is open. So that's another issue. And if I hadn't have investigated it a little bit further before I went and bought parts, we would still have had the issue of maybe DC on the offset even if the MOSFET was working, and still not knowing why we have no negative 15 volt REL. Now I know. So I'll have to replace this resistor. I think it's a 5 watt. It's too small to be a 10 watt. Maybe a 4 watt resistor. I don't know these type of resistors very well. I'll just stick a 5 watt 1K5 ceramic type resistor in there instead. Make it stand up a little bit better on the board. I don't know, but it's got to go through these two little pads here, which is yeah, kind of awkward fitting everything in without it, generating too much heat. I'll cobble it in there somehow and see if we make a difference. So I'm going to get a MOSFET and a resistor, and then hopefully we've got a working amplifier. Good morning. It's the next day and I've purchased the parts that I need from JK yesterday, the MOSFET and the resistor. And I'm going to pop the parts in and I'm going to see whether I've made an improvement or it's caused another problem. So there's only one way to find out, is to put the parts in and power up, test it and see if we've got a DC offset on the output. And there we go there, that's all the parts soldered in, MOSFET's in, the lead length was just long enough that I don't have to trim anything. New resistor is in and I've left him proud of the board and it's sort of cobbled in there, but I'm not really happy with how it looks. And I reused the spaghetti noodle stuff, insulation stuff, that's what it's called, off the old one. And I'll just test the old resistor out of circuit and you'll see that it is indeed definitely open. So I'll just test this resistor out of circuit. Here we go. Nothing. Bugger all. It is indeed open. So yes, this resistor is dead. Alright, so the next thing to do would be to hook it back up to the transformer. I'm not going to connect the input board for now. I still need to address this broken wire, but it looks to me that when it was crimped, the crimp end of the pin barely touched the insulation. There's no marking on there where it should be crimped. So I don't think it was actually crimped properly to start with. It was just crimped to the wire. I've left the switch disconnected because, well, we don't need it. I'm going to leave the output leads disconnected and just use alligator clips. So I'll hook this up across a multimeter and, well, we'll see if we've either fixed it or created a new problem. I'm hoping that I've fixed it. Alright, moment of truth. I've turned the desk lamp off so we can better see the dim bulb up top of the screen here. The multimeter is hooked across the output. Well, here we go. That looks perfectly normal. And look at that. There is no DC at all on the output. I'm just going to feel some components. That new resistor is cold. Cold, well, getting warm. Cold. 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 Driver is cold. Driver is cold. MOSFET is cold. Everything seems okay. So I might change my range to 5 volts. We're actually on AC, by the way, instead of DC. There we go, that's better. Still no DC on the output, it's only around about a millivolt. So I'm wondering if we've got a working amplifier now. So if I use something to touch the input pin of the amplifier, which I believe is that one, it is dancing around. You know what this means, don't you? It's dummy loading the oscilloscope time. Alright, I've got everything set up now. I've got the oscilloscope in the background. I've got the signal going in from a signal generator on a temporary JST connector. I'm leaving the input board disconnected for now in case there's a problem. The output's connected across the dummy load, times 10 probe. So let's turn on and see if we get an output. And voila, we actually do. And we're roughly at 1 kilohertz, which is, yeah, okay. Although, times 10 probe, what's that? That's 560 odd millivolt, which is not a lot. So let me just change to times 10. 5.6 volt peak to peak. So I'll wind the generator up. Whoa. Yeah. Right. The dim bulb's limiting the current. So we're getting to about 26 volt, which is perfectly fine. So it is actually functioning as an amplifier. I'm really happy about that. And nothing's getting unusually hot. So that was epic. So I might just change my frequency right down into the subsonic frequencies, which is about 100 hertz or so, 200 hertz. And the output is roughly the same voltage. So with about 550 millivolt going in, we're getting about 5.8 peak to peak out. So, okay. I'm very happy about that. So what I should do now is pull the board back out again, reapply some thermal paste to the transistors and stuff. Maybe get this closer to the board, I don't know. But first what I might do is I might actually switch over to the input board and just see if that's functioning. Okay, input board is connected. I'm going through this little home-built attenuator I made. So I'll turn him on. Inrush current's pretty good. Now I don't see anything on the scope. In fact, I see nothing on the scope. I figured it out. We needed like 100 hertz signal because of the crossover setting and filter network. But no, the input board is functioning. We're getting an output, which is kind of special. I've lost the pot, there it is, because that should now adjust it, which it does. Good, so I'll leave that full up and I'll increase the oscillator. Yeah, now that seems to be functioning fine. So, cool. That means that this one is fixed. And yeah, nothing is getting overly hot. So, okay, what I'm going to do is I'm going to reapply some heatsink compound on the transistors here, take the board back out, maybe fix that resistor a little bit better, don't know, and definitely fix this. So I haven't got the 3.15 amp fuse yet. I'll buy that later today because I wasn't going to put a fuse in it if it was just going to straight blow it again. But it appears to be functioning as it should. The inrush current is not so bad. So it should be able to handle being plugged into the wall without taking out the inline fuse or taking out the fuse in the house. So I'm happy about that. So let me get to applying some more heatsink compound, and we will come back in just a short moment. That's all you need. I'm not really worried about the stuff that's already over the micro washers because, well, it's still pretty pliable. I just want a little extra, and plus some on the new MOSFET because there wasn't any on there. So I'll secure the board down with the mounting screws first on the edges, and then I will screw the devices in. And I didn't bother touching that resistor. It's fine where it is, I guess. So yeah, I'm not going to bore you with watching me do up screws, but I will entertain you with this. And yeah, well, we'll get back to doing a final check on this and then fixing this stupid connector up the top here, which you can't see. Oh, that stunk. Alright, I'll get to retorquing these all up and come back. And it's all screwed back together, so now we'll do another power on test. Everything's connected. Well, we don't seem to have an output at the moment for whatever reason. Yeah, we don't have an output now. Yeah, you know why? I forgot to connect the bloody load to the output. That would help. So let's try that again. There we go. Nice. Beautiful. Alright, so now I'll address this stupid wire, put a new crimp on it. I believe they're the same type of connectors that I'm using. They look like it, so I just need to get another crimp pin. I've got plenty of those. Recrimp it, reconnect it. Then I can probably put this back in the cabinet. Alright, and there it is. It's back together for the most part. It doesn't have a driver, it didn't come with one. The only issue I had was with that transformer bolt thing at the end that came out the first time. Yeah, well, I couldn't get the center bolt done up because it wasn't lined up properly, so I undid it and I pulled it back out again. So it really needs to be like arrowdited in once it's screwed in, which may seem a little bit more challenging. But anyway, it's in there. Next time it comes apart, it'll just take the threaded bush with it, so not much you can do. Anyway, what I'm going to do now is I'm going to verify that we don't have any DC on the output by measuring across the output again, across the dim bulb, because I don't have the correct fuse. Fast blow will blow immediately as soon as I apply power directly. So yeah, let me get that set back up again, and then I will pump it, still on the dim bulb, into a speaker with an oscillator, and we'll see, well, how it sounds. Alright, the output is connected. I'm just making sure I'm in voltage DC, 5 volt range, speed high. Turn the device on. And there it is there. Absolutely nothing. Although that transformer is making quite a hum. That's alright. Alright, I've got everything hooked up into the test speaker on the floor, which I'm standing next to because, well, there's just not enough room here at the moment. So I'll turn on that. There we go. There is our signal. So let me just change the frequency range to 10 Hertz now. You can really hear the crossover. Do it that way. Yeah, so it's really effective around the 100 Hertz mark by the sounds. Oops. Let's phase shift. Yep. Okay, I'll try the other input. It's a lot lower. So I'll give it more gain. Whoa, that was a bit too much gain. Yeah, okay. Yeah, nice. It's not doing too bad. It's not smoking. Can't smell anything. Can't see anything either. But the heatsink feels cold, so that's all I'm really concerned about. So I'm actually pleased with how this turned out. It was a simple fix, which sometimes they're not. When there's DC on the output, it can be any various different part of the circuit that's not functioning correctly. But the video's not over just yet. I do want to actually get that new fuse so I can actually power this directly off of the power point. Hopefully it doesn't have any disastrous results. It shouldn't do. The inrush current on the bulb looked reasonable. And I actually want to do a full output power test to make sure that it's pushing, you know, what I'm going to assume is over 100 watts, which is what it's supposed to be. Just to make sure that it is completely working properly, and I don't have to go in there and replace capacitors or stupid stuff like that. So I will get that, and then we will pick this up again tomorrow morning. Well, it's the next day, and I've got two new 3.15 amp slow to low fuses. I always buy two when replacing a fuse that's blown in my device, just in case something disastrous happens and I blow one straight away. These are $1.60 each, so they are getting quite expensive now for fuses. So anyway, today is the day to take that REL T1 subwoofer off the bottle, i.e. the dim bulb, and see if it'll power directly from the mains without anything bad happening, like just blowing the fuse in the house. If it blows the fuse in the house, that means the inrush current of the transformer is too much and really should have a limiter on it. And it'll also annoy me because I'll have to go out and buy some fuse wire because there isn't any in the switch box. Anyhow, let me get the new fuse into the subwoofer. I really do not like these type of fuse holders. Alright, so I'll just take my fuse out. The correct way would be good. I'll pop the new one in. Now, I'm just going to go for broke here. It's plugged directly into the wall, well, into the power board anyway. Got my multimeter hooked up across the output connection just to, you know, double check the DC. And, well, am I confident that it's not going to blow the house fuse? Semi. Let's try it. Works fine. The thing is not to be scared, just do it. If it blows the fuse, it blows the fuse. Less than about 2 millivolts on the output, which is that's reasonable. Alright, now to hook up the oscilloscope and dummy load, signal generator, and see what sort of power output we get. Okay, everything is hooked up. I've got the dummy load sitting on top of the unit. Well, it's actually on the bottom anyway. I'm not going to be running that much power through it for a long period of time, so it's not going to damage the cabinet. I've taken Dave Jones from EEV Blog's advice, pro tip about keeping wires from just like pulling out of things or disconnecting or shorting together, is I've just taped the ground wire to the cabinet so it's not floating around. And the oscilloscope is preset to 60 Hertz, and the time base is already adjusted so we can see output properly. So I'll turn him on. I don't know where my attenuator is set to, so make sure it's fairly well down, which it is. So I'll turn it on. We've got an output. Alright, I'll increase the gain. Maybe. Maybe not. I've got an issue. It seems to be... Yeah, well, that's interesting. Move the thing must be loose. There's our actual signal. That's a bit better. But it's not increasing any higher than that. Okay. I might have to break out the other oscillator. Right, now I can't get it into clipping, but it's at 68, 69 volt peak to peak or so. I don't know if that's right though. Although that is 74 watts RMS, so it probably is right. Although with those supply rails I'd expect a lot more out of it than that. But okay, that's enough to be giving deep booming bass. I guess the thing is, it's probably not designed to go into clipping. I mean, I could inject the signal directly into the power amplifier's input and see, you know, whether the amplifier goes any more than that, because, or where its clipping point is, because the input board may be actually limiting how much power is going into the power amp. I don't know. I really need to look up the specs of this to see what its power output's supposed to be. According to this, it's supposed to be a 300 watt class AB amplifier. Yeah, it's not quite getting to that power. Although that was at 60 Hertz, I should try probably a different frequency, lower frequency. Okay, so I need to get here, and I will go here. It's too far. Alright. 10 Hertz, but it doesn't look like we're actually getting any more power out of it. So I'll up the level control. Oh, we're actually going into the clipping. So if I can back that off so the clipping goes away and it becomes symmetrical again. It's still around the 69 mark, maybe 71, you're getting a little bit more power out of it, but not much. So what does this mean? Is the thing actually functioning correctly, or have we still got an issue? Well, this is what I don't know. We could have bad capacitors, electrolytic capacitors on the main board, it's possible. I guess the only way to test this is to, at 1 kilohertz, directly injecting the signal into the power amplifier instead of the way it is now, and see what sort of results we get off of the amplifier then. Well, I'm going to take a quick smoke break first and then come back and do that. It's going to be a little bit awkward trying to get in there now, but I'll try. I hope I'm not boring you guys, but I had to pull the amplifier back out the cabinet to give me enough room to disconnect the input cable. I've got the oscillator going directly into the power amplifier. However, from what I can see, I'm getting less power out of it going directly in. So the input sensitivity of this amplifier must be pretty high. So that input board is actually giving us a little bit more gain. But yeah, I can't even drive this into clipping, and my oscillator output is full up, and I'm only getting 36 odd volt peak to peak, so it's a lot less than what it was coming off the input board. So I'm pretty much going to assume that this is probably working fine. So, alright, well, I'll put it back together and close this one out, and I'll leave it up to you guys in the comments to decide. Is 74 watts a reasonable expected figure for this thing? I'm thinking it may actually need a preamp or benefit from it. However, I've got it hooked up to the test speaker on the floor and my laptop. The laptop's up at 100%. I've currently got the 0.1 input control around about the 9 o'clock position. So it's not very loud. So I'll play a track, Emotional Mess by Amy Lynn. And it is working. That driver's not really designed for that. That track sounds so weird when just listening to the audio of the bass frequencies. Okay, I'm going to say that that is actually working as it should. It's certainly throwing quite a bit of bass, and I didn't have that volume control up any higher than about the 11 o'clock position. Any higher than that, I'll probably end up destroying the driver. That is a response driver though, so yeah, it should be able to handle it, but it's only got a RMS wattage handling of about 70 watts, so I've got to be careful. However, it's sounding like it's working. I can't actually hear any difference on the crossover control when I rotate it, but yeah, it doesn't seem to be making much difference. However, it is working as an amplifier, and it's throwing quite a bit of bass. So I think I'm going to close this one out by saying thank you for watching, and if you enjoyed this video, please remember to rate, comment and subscribe below. And you can catch me in the next video. This is Yasho 30 saying see ya, have a great day.